Hello, everyone. Let's model this in this lesson. We based the CAD plan elevation behind the node drawing. There are sample drawings. Biochemicalize the whole model. Here's the floor plan. And then here's a sample of what it looks like. Let's take a look at the biochemical model. Because of this building. It's square and straight though. But it's still got a certain look to it. What about us? Before the construction. Biochemistry out of the model. The first is to check the drawings for errors. The second is to lay down the material according to the model. And then you can also calculate the cost based on the model. What about this model? You can see its structure. It's detailed. The model can clearly reflect how these edges are transitioned. Including these places. What if there are aesthetics and problems? We can also make optimization changes in a timely manner. If the line is rectified, that's a big price to pay. And today, let's do the curved part of this. First, let's open the sample drawing. Let's biochemistry this part out. First we have to open the courseware. In the building curtain wall aluminum office network knock information update 3 we have updated a lot of cases. Then open this. How to quickly model a normal straight facade according to CAD. And then, here's how it's built. And the construction plans. First you do this. This archive map and this node map we both need to see. Then we open this file merge with Rhino, then open the invisible building with the shutdown. Of an unmarried couple, be close. I've opened it now. First we need to put the structural model and the CAD. The plane elevation has to be guided in. And then, categorize layers well. What about the ones you don't need? We hide it. The first thing we did was this demo, and this sample. We'll have to channel it too. Insert to plan, elevation, section. We all need to find this place to go. About importing CAD drawings, structural model, then merge the layers, aligning the axial grid. I've talked about this many times in other videos. I won't repeat myself here. You can open a larger image of this curved building. I'm here. First made a big case diagram of a curved building in Rhino. First we import all the frequency facets needed for the big case. We push the process from the result. Let's take a look at what's included here. Includes aluminum panels. And glass. Aluminum profiles. And civil engineering. This is the overall structural model. We'll go in first. Then the building walls. And then there's the dividing line. Aluminum panel divider. And then there's this buried piece. Fixture, partition of wall, galvanized iron sheet for building construction. There's a railing here. It's 80 × 80 squared. It's 102 × 60. You'll find this squared off then, all normal to this surface. It is a vertical relationship, and then there's the 60 × 60 square pass. Of an unmarried couple, be close. We open the sample merge, and there's this one curved building off. We begin by extrapolating from the result to the process. Let's look at how this glass is generated. Where's my sketch? It's all curved glass and curved aluminum. Let's open up its floor plan. Just the floor plan. The distance is marked as a straight line. We're going to change the arc to a straight one. It is the known substitution. So what's the first step? We're going to convert this yellow curve from CAD to this straight line. We can use the rhinoceros approach to spread this midpoint directly. Find this midpoint. And this center point. Let's link a thread like this. What happens after the connection is made? We choose this line. Then find the command for the curve in the Grasho. And then we'll pick it up. Pick up a line. Then you can right-click into the back of the tube. That means that after you delete the new entry this tube, it's still running. And what happens when you get this line? We use this merge command. Maybe we're trying to lose a couple of threads. And the second wire? We can hook it up, too. Then we move through a couple of moves to get to these two pieces of glass. What about the location of this glass? You'll need to base it on the galleys. First of all, let's open the sample drawing. Let's take a look. We'll start by extruding the glass in the following section. Its total distance is 450, so we're extruding 450 in the z direction. But then, where's the line we just drew? Its elevation is 0. So we're gonna move down to 150. So move. Then the opposite direction of the z-axis. That's what you need to add to move down 150. And then, we can then get the following piece of glass. Similarly, we squeeze this piece of glass out based on the large image. Then move it to its proper height. Then we use this to give it a color. And the color? We can pick a transparent color here. What happens when you color with this? What about when we can use the rendering mode? That's the color it's going to be. What happens when we switch to coloring mode? It's got nothing. Only if it's selected. And then what? We're going to make these aluminum rows. Let's take a look at this aluminum row material. There are horizontal and vertical aluminum profiles. It's a look like this, but let's simplify it. We can just make a rectangle for it. What about this look? This file will then. There's a lot of cards. It's a lot bigger. What if you really need to show this look? We can replace them all with blocks. We can get the elevation of each aluminum row with this big picture. And then, let's take this line and put it together. If you say you don't have a combination, you need to combine them. What if it's a combination? Don't do it with this command. You can also frame it with Rhino. Then click on this combination. And after the combination, let's look at the first elevation you formed. We'll make it 2.8 meters. Just move it. Move to the C-axis at 2.8 meters. What about after the move? We'll put it on a work surface. That is to say, the first and the last wear a work plane. What about this command? It will give it a vertical working plane. Where did you enter 1? Would represent a period of. What if we say 10? It's gonna have a time slot. There are many work planes. Input 1 segment is 2 work planes. If this work plane of yours is showing too small, you can change it here in the display. Let's say you change it and add another 0. Press enter again. You will find this work plane, it will show up great. Subtract a 0 obstacle to enter the carriage return must be pressed enter. Then determine the size of this work plane display. To make sure that its x-axis is vertical. We can add a command for this. Actually, in this case, it doesn't matter if you add this or not. It's all vertical. Let's open this node graph. Let's take a look at this travel material. Its total length is 154. Its width is 70. Where the distance in front of it is 30. That means this glass to this front it's 30. Because we just drew this glass line. It's actually in this position. So let's take a look at this glass line then. Its distance in this direction is 30. So is this direction positive or negative? This is the x-axis. This is the positive direction of the y-axis. Then this is the negative direction. So that's minus 30. What about this direction? It's positive 124. So what does it add up to? That's exactly 154. And what about its x-axis? We went from 0 to 70. So when you look at the elevation of this traveling platform, what about this distance you're moving? It's the distance below this traveling platform. Then there's a rectangle at the beginning and end. But what about the first track? We just need to select a rectangle, so let's say you choose both. You take it over, you'll find this made model will have certain problems, so let's pick one of them. So we make one. What about the other travel materials? You just have to get this elevation out right. What about the others? We can just copy it like this CTRL-C CTRL-V. And then, just change the number. What if it's easier to say you need a battery pack? Then you can make a move to it on top of this one. Let's say this one you move 800 and it's another one. And then, there's no need to copy so much. Because it's easy to copy. So you just copy it. Change this. Changing this elevation would also be a good idea. And in the end, you've done all of this. Connect it with this linking symbol, and then, give it a color. And then what? We're gonna make this aluminum. First we're going to take this cross-section, extract it in CAD, then locate the proper elevation. What happens after the CAD is imported? We'll take it from CAD, retrace this line. Or maybe just blow up the CAD again. Fry more with this. Blow up its chunks. Then disband the group. And then, extract this edge line directly from CAD. So what happens after the extraction? We're going to use this 2-point orientation from Rhino. Put it in the right place. What about when you put it in the right place? Let's take this A word with GRA. What about when you pick it up? Put it in the tubo. We found this one as its path. This one serves as its cross-section. What about our command to use the monorail? Sweep it out. And then this aluminum plate down here. We do the same by positioning this line at the right height. We use the elevation of the aluminum track closest to it. Then give it a sweep out. And then what does this mean? This is the one I chose to hide. Then the line doesn't. You only have to click on it to get it. What about this thread? It won't fall over. It looks like a mess. It's a way to hide. And then what? What color is this aluminum plate? We can give it a